Okay, we are going to learn about selection of field instruments, especially Orifice plate and DP transmitters. Why this selection of flow meter is very important. So, if you take a pipeline, the fluid flowing through the pipeline may be toxic, can be flammable, abrasive, radioactive, even explosive or corrosive. And you have single phase liquids, clean gases, water or oil, or multi-phase, example slurries and wet stream. So to handle this variety of fluids, there is many type of flow meters are developed over the period of years. So the very essential type of flow meter is DP flow meter, which is very widely used. So this flow meter relies on differential pressure between two pressure taps. Here you see high pressure tap and low pressure tap. The difference in pressure drop is calculated in terms of volumetric flow rate. Okay, example are orifice, nozzle, venturi and elbow. So they follow square root relation. Okay, especially this is the pipeline. This is high pressure tap and the area is A1. So this is low pressure tap, area is A2, velocity V1, velocity V2. The difference in pressure is del P. So when we will calculate the volumetric flow rate QVL, given as K into square root of del P, where K equal to A1 A2 square root of 2 divided by rho times A1 square minus A2 square, where del P equal to P1 minus P2. So accuracy of these DP flow meters, Orifice, nozzle, venturi and elbow flow meter. Orifice, the accuracy is plus or minus 0.6%, nozzle is plus or minus 1%, venturi plus or minus 1% and elbow plus or minus 0.5%. So when selecting a flow meter, Reynolds number is very important. So Reynolds number, with the help of the Reynolds number, we can decide whether the flow is laminar, transition or turbulent. So what's Reynolds number? It is the ratio between inertial forces to viscous forces. When the Reynolds number is less than 200, we call the flow as laminar. If it is 2000 to 4000, it's transition, and the Reynolds number is greater than 4000, it's turbulent. First we will see Orifice types. So there are variety of Orifice plates. The first type we are going to see is concentric Orifice plate. Otherwise it's called square edge Orifice. So, this concentric Orifice can measure single phase, liquid, gas products along with flange taps. Mostly this Orifice plate is mounted by means of flange taps. Next is quadrant edge. So you can see the Orifice plate is made into quadrant edge Orifice. That's why we call it as quadrant edge Orifice. So from the picture we can understand the shape of the Orifice plate. So this can be used for fluids with high velocity If you have pipe Reynolds number below 10,000, if the Reynolds number is less than 2,000, you can go for quadrant. Eccentric. So this is eccentric orifice where you see the bores are off the center. I mean they are eccentrically placed. So it can carry non-abrasive solids. The solids can move, or gases with or gases with small amounts of liquid. So orifice selection consideration. How to select an orifice? So quadranted orifice is considered if the Reynolds number is less than too low or less than 1,000. So orifice we should specify with proper flange rating to account for proper bolt circle. Okay, and beta ratio. Beta ratio, it is 0.25 to 0.7 for non-commercial and 0.3 to 0.6 for accounting meters. Okay, and we should, while calculating, we should take account of drain hole as well as vent hole. So dB meter characteristics. So they are recommended for clean, dirty liquids, gases and slurries. Rangeability is from 3:1 to 6:1. Maximum flow 95% of rain. Pressure loss, it's from 20 to 60% of pressure head. Accuracy is 0.5 to 4%. Straight run requirement is 5 to 40 dm upstream and 2 to 5 dm downstream. So viscosity effect will be very high in case of dB meter. And size, what is the recommended size? 2% to 2 inches to 24 inches. Connection, so it depends upon meter type. There are different types: flange taps, corner taps, inner contractor taps. Yeah. What is the type of output? It's square root. Volumetric flow rate is the square root of delta V. That's why we call it square root relation. So summarize. So the flow meter type, it's differential pressure. Primary working principle, it's pressure drop. A restriction is created and the pressure drop. Quantity measured, volume. Advantages: low cost, versatile, robust and variety of action. Disadvantage: it's square root dependent and affected by pressure density changes, high pressure drop. Okay, except nozzle, all other meters have high pressure drop. Meter name: orifice, nozzle, venturi, elbow, V-cone, pit-arch, handlebar. Okay, thank you.